Here we go. We're doing transformations of graphs. It'll be so much easier as we dive into it, but there are three major types of transformations. A reflection, I'm going to do that in green because I'm a color coordinating guy. A translation, which is a slide left or right, and a dilation, which is a size change. And there's just three steps right here that if we just dive into these questions, it will be a whole lot easier to understand. But what you're going to really want is to save this practice worksheet to look at those three steps. Hopefully by the time we're done with this, you'll kind of have them memorized, but here's what they want us to do. Check it out. This guy right here. Would he be a parabola if we graphed him? Yes or no? What do you think? Yep, we got ourselves a squared guy. What we have is a little bit of tricks to know what that parabola should look like by doing the graph transformation theorem. So follow along with me. Number steps 1, 2, and 3 right here on your paper. And here's what I am grading. I'm grading to see if these three things happen. Do you see like step 1 on this note card that I kind of put on your worksheet says, has this guy been reflected over the x-axis? I just want to talk about that for a second. What would that mean? Like, here's a plain Jane parent function parabola, right? If it was vanilla, are you with me on that? If I reflect it over the x-axis, what would it look like? It would do that. Would you agree with that? Do you see how it just totally reflects down, right? So that changed. What somebody said was the openness. And you already know how to tell if this parabola opens up or opens down. Could you tell me, does that parabola open up or open down? Doesn't it open up because the a value is positive? Who is the a value in this case? It is 1. But here's what I'm going to do. I'm going to be like a highlighter guy. Do you see in vertex form, we've got all these fancy little spots right here. We've got our A, H, and K that we talked about last time. Step 1 says, did this guy get reflected over the x-axis? And all you got to do is look in here, and you see like there's those same things right there. There's A, there's H, and there's K. And we're looking to see if A is negative. It is not, so we're going to put a dash right there. This guy does not get reflected over the x-axis. Meaning, when we make a sketch of this parabola here in a few minutes, it's going to open up. Because didn't the normal parent function open up in that case? So our new parabola, with all the sprinkles and flavors in it, is also going to open up. But then there's this translation, which is probably one of the easier moves as well once we get used to it. We're going to put a giant capital T right here for translation. And I want to know where this thing has moved like left and right. And I also want to know where it has moved up and down. And according to this cheat sheet that we have right here, you always get translated H comma K, where H is how you move left and right, and K is where you move up and down. So could you tell me, look back to this guy, who's H? Is it 1 or is it negative 1? Do you remember, like, we kind of have to do like opposite game on this situation right here? So who is the H value? He is really negative 1. And what that does is that totally moves you 1 unit either left or right. Like, this is the x value of the vertex, and how do you feel about the x-axis goes left and right? Are you cool with that? So what do you think negative 1 means? Move 1 unit left or 1 unit right? To the left, right? So that's what that negative 1 means. Then the up and down part is your K. Who is our K value? What you see is what you get on that, right? So that's going to be a positive 3. What do you think that means? Up 3 or down 3? It's positive, so up 3. Are we cool? So this parabola has started at 0, 0, just like this plain Jane right here. And so far, he still opens up. He's got to move 1 unit left, so and then 3 units up in that case. But then the weird part is they want to know how this thing has been dilated. Is it the same size or different? I'm going to show you it with my arm. Sorry if you're watching on the video, you don't get to see this, but this is like a normal parabola. Are you with me on that? Could he also go like this and get like a little skinnier in that case? Or could he also go like that and get like a little fatter in that case? That is called like either getting vertically stretched or vertically compressed. We're trying to see if this thing has been dilated at all, and here's what we got to do. We got to look at this guy. Do you see how they want us to look at the A value? But they got those bars around it. Do you remember those bars meaning absolute value? Like if I ask you to take absolute value of negative 2, what does that mean? Absolute value means make it positive, right? You know, even if it already was a positive number, just keep it positive. So they want us to look at the A value. Could you tell me how much the A value was again? How much is the A value? Is 1. And make him positive. It's like, bro, he is positive. So we're thinking of the A value to be 1. Cool? And we got to ask ourselves this question. Is 1 greater than 1? Yes or no? Is that happening? Is 1 bigger than 1? That's not true. So it did not get vertically stretched. Is 1 between 0 and 1? What do you think? Is 1 between 0 and 1? 1 doesn't count, right? There's no equal to bar. Is 1 between 0 and 1? It's a tricky question, right? What do you think? Yes or no? Nope. It didn't get vertically compressed either. I know that's the weirdest step. You will get very, very used to it here, but here's the moral of the story. What was the A value? Say 1. If you take something times 1, will it change size or stay the same? Yeah, you just multiplied it by 1. It's not going to get bigger. It's not going to get smaller. Are you with me? It stayed the same. So the parabola will not get skinnier and it will not get fatter because we took it times 1. What if you took it times 2? If you took anything times 2, would it get bigger or smaller? It would get bigger, right? You know, so we'll kind of see when that A value is fancier, right? Things are going to happen. But here's what we do. We have totally realized that this is our parabola, and all we got is he's going to do this. This means it has not been reflected over the x-axis, so it's going to open up. So here's what we'll do. Put your pencil at the vertex of 0, 0, but don't put a dot there. Just kind of put it right there and move like roughly 1 unit left. I know you don't have any scale, so we're just kind of guesstimating. 1 unit left and 3 units up. And put yourself a dot there. And we'll call him 1, -3. Excuse me, I did that wrong. -1, 3. Okay, cool with that ordered pair right there. We're going to sketch us a parabola right here. Which way should this parabola open? Up, down? Up. And then you tell me, normal size, skinnier than normal or fatter than normal? Nothing happened here. So what do you think? Normal size, skinny, or fat? Normal. So how wide is that? That's a good question, right? It's just a sketch, but that's roughly our normal size looking parabola. We're just going to have to kind of roll with it. I know this is very, very strange. After the third one, I'll start feeling you out to see how we feel about this. We're still only on the first one, right? But we're not quite done because here's what college algebra is going to make you do. Write a sentence about this. So here's what this guy was. This was fancy schmancy, like all kinds of flavored up ice cream parabolas right here. It's got some flavor on it. We got to strip him down to vanilla. So I don't care about this g of x. We're just going to pretend he is y in that case, just to make today a little easier. What would the parabola strip down to be if I got rid of all the flavor? What is the most plain Jane parabola's equation look like? Y equals what? Isn't this the most plain Jane parabola you could have? Y equals x squared. So here's what we're going to say. We're going to write a sentence. We're going to say, sorry, I hit the wrong button, the graph of, so let's kind of write our sentence together as soon as I get an eraser. The graph of parent, so that's going to be y equals x squared. So almost every question today will kind of have that. But you can do the graph transformation theorem on everything. You can do it on lines, you can do it on parabolas, you can do it on absolute value guys, and all those graphs that I used to have hanging up there. So the graph of this guy has been. And then here's the easy trick. Anything that we wrote down in the 3 steps goes into the sentence, and we got to put it in English, not in abbreviated form. So if it would have been reflected over the x-axis, we would have like put that in our sentence. But that didn't happen. Are you with me on that? What does this big old fat T stand for? Stands for what? Translated, right? So we'll say the graph of y equals x squared has been translated. And then what does this -1 mean right here? 1 unit where? Left or right? Left. So the graph of y equals x squared has been translated 1 unit left and 3 units up. Are you cool with that? You will definitely not like writing these sentences. I totally understand that. And the sooner you can show me that you understand what the sentence should be, we'll kind of skip that today, but you definitely have to do it on homework and you definitely have to do it on the quizzes, right, and the tests. But man, that's only one example. Let's make things a little clearer. So let's roll with this. here is a parabola. When they ask us to do the graph transformation theorem, which you'll hear me call purple note card all the time, because in Algebra 2 they give you a purple note card to do this, because there's actually 4 steps to it and it's a little harder. We're keeping it basic and only doing 3 steps, so we'll always number 1, 2, 3. And just for your benefit, even though we are still pretty familiar with it because we did it last time, these are the 3 things that we're looking at. We're looking at the A value, we're looking at the H value, and we're looking at the K value. First question, these are the things you got to memorize, is what's step 1? Step 1 is, has it been reflected over the x-axis? You got to look to the A value to see if he is positive or negative. What do you think? Has this guy been reflected over the x-axis? So here's how we'll write it. You'll learn in geometry that a lowercase r stands for reflection. Do not use a capital R. And then we're going to put a little subscript of x because it has been reflected over the x-axis. But talk to me, dude. What does that mean? Here's how it started, and I'm going to reflect it over the x-axis. What does it mean? It's going to open which way? Down. When we make our sketch of this, this parabola's got to open down because it has been reflected over the x-axis. It started right here, and then when we added this flavor to it, it says, oh, sorry, I got to do that now. It has been reflected over the x-axis. So then, next move, where has it been translated? It's always going to go H, comma, K. Who is H? Tell me what color he is, the blue one or the pink one? The blue one. Is it 1 or -1? That's our opposite game. And what does it mean? 1 unit, it's been slid 1 unit, left or right? What do you think? To the left. Cool. Then we got to go K. K is the pink one up there. Do we want to keep the 2 or do we want to change the 2? Keep it. 2 units up, right? Up. So H goes left and right because it's like hanging out with X all the time. Isn't it like the X value of the vertex? And K is like the Y value of the vertex. And then let's see if there was any kind of dilations, which is a size change. We need to focus on A. Who is A? -1. But then you see how it's got these bars around it? Make it positive. What is -1 if you made him positive? 1. Is 1 bigger than 1? Nope. Is 1 between 0 and 1? Nope. Will this thing change size at all? Nope, because you just took him times 1. People are like, well, didn't you take it times -1? What did the negative do? It just flipped him over the x-axis. That's all it did. The A value is really 1 in this case. So let's make a sketch of the parabola. And here's what you got to do. Your brain has to do this part in pink. Which way is this bad boy going to open? Up or down? Down. Then let's go move the vertex. The vertex started at 0, 0. We got to go 1 unit left and 2 units up. And watch my brain. Watch this. I got to put the ordered pair because there's no scale, but look where I'm going to put him. How come I put him above the dot instead of below the dots? Because the parabola is going to open down, right? You know, so I don't want to have that in the way. And how fat should I make my parabola? Normal size, skinnier than normal, or fatter than normal? Did not get dilated at all, so he is a normal size parabola that opens down. Let's write the sentence. The graph of. And who is this guy when it's all stripped down to vanilla? Y equals what? X squared. That is the most plain Jane parabola you could have. Has been. So every sentence will start like this, except for the fact that this, might not be y equals x squared if we do it to a different type of equation. If we do it to an absolute value guy, if we do it to a line, if we do it to a cubic, you know, that'll come your way in Algebra 2. Has been. Then anything that happened in the 3 steps, you put them in the sentence in that order. What does this mean right here? This means what? Reflected over the x-axis. That is very important because in Algebra 2 you will also reflect these over the y-axis, but that's a little too much for us this year. So the graph of y equals x squared has been reflected over the x-axis, translated 1 unit left. Are we cool with that? And 2 units up. The whole reason why we're having you write these sentences is 1, because college algebra makes you, and 2, please realize that sentences start with a capital letter and end with a period. Like, let's write a complete sentence there, please. Yeah. And again, if you don't like writing the sentences, I'm on your side. I type them out because they're easier to type than to write. Give me one more example before I start turning us loose on things. We've only done 2, right? So let's try a third one. Is this even a parabola? Yes or no? Sure is, right? So let's do steps 1, 2, and 3. And now we get interesting. I'm going to highlight the a value for sure. Isn't a the number in front of x squared every time, right? So that's this guy right here. But it doesn't have the parentheses with it this time. But I still got to do and find h and k. So here's my question to you guys. Who's that negative 1? Is that negative 1 the h value, or is that negative 1 the k value? Discuss what you think real quick. Because this negative 1 is not in parentheses, who do you feel that he's got to be, h or k? This is the k value. So who the heck is h? What if I wrote it like this? Is this the same thing? Negative 1/4 times x minus something squared minus 1. What number would I have to put right there for it to be the same as that? What are they adding or subtracting to x to get x back? What do you think? 0 or 1? What do you think? Is x and x minus 1 the same thing? Or is x and x minus 0 the same thing? What do you think about x minus 0? What's x minus 0? It is x. Are you with me? So they put nothing in the parentheses. It's kind of like they're right there. Do you know what I'm saying? And they put nothing in there. So let's roll with this guy now. Has this guy been reflected over the x-axis? What do you think? Yes or no? That is a yes. So we'll do the r sub x because this a value is negative. Let's get him translated. Big fat T right there. Left or right first? Up or down second? Who's first? Well, yes, like number-wise. What number do you want to put there? 0. It has not moved left or right. And how about up or down? It went with 1 unit which way? Down. And don't we put that as a negative 1? Cool? How do you feel about those two real quick? That was tricky because they had a 0 in there as a disguise. Now, let's see if this thing gets dilated. Can you tell it's going to get dilated? Because the a value is not which number? 1. But you got to think he's positive, right? Isn't it negative 1/4, right? Pretend he's positive because of this absolute value thing. Is 1/4 bigger than 1? Yes or no? Nope. So that didn't happen. Is 1/4 between 0 and 1? Yes or no? It sure is. So what does this thing do? It gets vertically what? And you can abbreviate it like that in this 3 steps. It gets vertically compressed, and then put this times 1/4. Where did I get 1/4 at? That's the a value, right? So if the a value was 1/3, it would get vertically compressed by 1/3, right? So here's the real question. Please use your hands if you need to. I'm going to show you with my hands. What happened to that parabola if it gets vertically compressed? Does it get fatter or does it get skinnier? Fatter. Hey, watch this. Why is this very different? Why is this not vertically compressed? What is this? This is horizontally compressed, which does happen to graphs, right? We're not going to deal with, we're only doing vertical, right? So it's got to go up and down. Are we cool with that? Vertically compressed means it got what? Fatter. So here's what we'll do. Let's sketch our parabola. First question, in your brain, which way does it open? Up or down? Down. Cool. Let's move the vertex. 0 units right, 1 unit down. So got to have that ordered pair because there's no scale on this little sketch, right? So I got to see where's it at. You see how I went nowhere left or right, and I went 1 unit down. Parabola's opening down, and it's going to get what again? Fatter or skinnier? Fatter. So you know the normal parabola that we normally make? Let's make him fatter. So how fat? I don't care. You know, I can't judge you on how fat you made it. I just want you to have, okay, I got a basic normal parabola, then I've got me a fat parabola like this, and then later we'll have ourselves a skinny parabola as well. But I care that it was fat. Let's see if you can write the sentence. The graph of And if we do this sentence right, we'll stop writing the sentences today. The graph of, what do you want to put right after that? The graph of y equals x squared has been. The graph of y equals x squared has been. Then you go to your 3 steps, and you write them in there in the order. First thing you write, it has been what? Reflected over the x-axis. Has been reflected over the x-axis. Then it has been translated 1 unit down. You don't need to say 0 units right. Do you know what I mean? It's like it didn't happen, right? So if you do, it's kind of okay, but it's weird, you know. So it's been translated 1 unit down. And then here, I don't want you to abbreviate this, right? I want you to write it out. Vertically compressed times 1/4. The words are spelled for you on that note card right there, like on your paper. Here's the words vertically compressed if you don't know how it's spelled. How do you feel about what should go in the sentence? Do we feel that? Can we skip those for the rest of this lesson until I tell you we got to come back again? Because there is a couple more sentences I do want to write. But just to save a little bit of time, here's how we'll skip them. You'll have to say them out loud to me. You either say them or write them. Your choice. Sound all right? So let's do this. Could you do this with a neighbor? Try steps 1, steps 2, and then we'll do step 3 together. See if you can get step 1 done, step 2 done, and then we'll do step 3 together. Step 1, has it been reflected over the x-axis? What do you think, yes or no? You're looking at the green guy, which is the A value. If he is negative, that answer is yes. So what do you think, yes or no? Yes. It's okay if you weren't sure about that. You know, we're still new at this. The next thing is what? Like for those who don't know, you go look to like in the upper right corner. It's like, okay, what's step 2? The translation thing, right? So translated, how do you move? H comma K, right? If you can identify H and you can identify K, that's a freebie. What do you want on this one? 3 or -3? Opposite game, right? And then 1 or -1. What you see is what you get. Cool. That means 3 units where? 3 units right, 1 unit up. So let's do the dilation part together. Who is the A value if you made him positive? 2. Something's going to change, right? The only time it doesn't change is when it's 1, because we're just taking stuff times 2 here. So question, is 2, like the absolute value of the A value, bigger than 1? Yes or no? So this happened. It got vertically what this time? Vertically stretched, which I'll let you abbreviate as STR. Vertically stretched times how much? 2. Tell your neighbor what that means. Did it get fatter or skinnier? Use your hands if you need to. It got vertically stretched. What do you think? Fatter or skinnier? Skinnier. So let's do it. Talk to me out loud. How should this parabola open? Up or down? Down. Move the vertex. 3 units right. 1 unit up. And then we're going to sketch ourselves a parabola skinnier than normal, right? That would be like this, like real skinny in that case. So, but it's got to open down, so skinny boy. This is what I would call in red my normal size parabola. Do you see how that one is like skinnier than that in that case? So, and then let's see if we can do the sentence out loud. I'll start. You fill in where I stop. The graph of y equals x squared has been reflected over the x-axis. Anything else? Translated 3 units right, 1 unit up, and vertically stretched times 2. Cool. All right, let's roll to the next guy. All right. Looks like I kind of have that done already. So why don't you and a neighbor try your 3 steps without me. Okay. Here's my 3 values. A. Who's this? Is he H or is he K? Better question. Is that in parentheses or not in parentheses? That's in the parentheses, so that is who? H, and then K is always out there, right? So has this guy been reflected over the x-axis? What do you think, yes or no? Nope, because that number right there is still positive. So what's that mean? Parabola is going to open up still. Cool. Translated, this has got to come first. Do you want 4 or negative 4? Negative 4. And then how far up or down did it move? Nowhere, right? Nowhere. Did it get dilated? That A value is 3/4. Make him positive. He is 3/4, right? So what do you think? Vertically stretched, that'll happen if the A value is bigger than 1. Or vertically compressed, that'll happen if the A value is between 0 and 1. What do you feel about 3/4? Vertically stretched or vertically compressed? Vertically compressed times 3/4. Make a sketch of that parabola. So how do you feel about that? He opens up, right? You move 4 units left, and he is vertically compressed, so isn't he fatter than normal in that case? Rock on? How do you feel about the sentence? Did I do it right? The graph of y equals x squared has been translated 4 units where? Well, is that right? That's a weird word. Is that correct? So yes. And vertically compressed times 3/4. All good? All right, let's see if you can do the whole thing. The 3 steps and the graph. You don't need a sentence. We'll do the sentence out loud. The 3 steps and the graph. So check yourself. Does that work good? It has been reflected over the x-axis. Yes. Translated 2 units where? 2 units left or right. One of those two is correct. 2 units where? Right. And 6 units down. How come it didn't change? That's not a 1. That is a negative 1. How come it didn't change size? Because you got to take the absolute value of it, which means it's got to be a positive 1 in that case. So then the sketch, how do you feel about that bad boy? It's got to open down, move 2 units right, 6 units down, and then it's normal size parabola, right? Normal size parabola. Cool. I'm going to go back. You tell me what the sentence should say. Fill in where I stop. The graph of has been reflected over the x-axis, translated 2 units right and units left. Cool? Sound good? Because yes, you will have to write these sentences. I'm just trying to save you time. I said left on accident. I'm sorry, it should have been down, right? Did I say left on sorry about that. So it's 6 units down. Sound okay? I can always tell when I say something wrong by looking at your face. You go, that's not right. All right. Hey, how do you feel about it? Does it feel okay? Cool. Let's mix it up. What's different? What's different? Tell me about this shape when we graph it. Is it a parabola? Nope. And you've had a few of them on your homeworks recently. What do those bars mean again? Absolute value. Remember the graph of this. It's a long, long time ago, but how do you feel it looks like a V, right? It's like it's not a true parabola. It's a V. Is the vertex still at 0, 0? Yes. So it's the same concept, bro, except it's not going to be a parabola. A, H, and K are in the same locations. So A is the number in front of the bars. H is this guy right here. He's still going to be opposite game, right? And K is right there. So let's do 3 steps. Step 1, step 2, step 3. Has this absolute value guy been reflected over the x-axis? What do you think, yes or no? Nope, because that number is not negative. Where has it been translated? Get it down. See what you think. It's the same as before. What do you want? A positive 1 or a negative 1? 1, positive 3, right? So 1 unit right, 3 units up. And let's talk. Has it been dilated? The A value is 2. Are you with me on that? Right? 2. So if you got to flip back to kind of look, you're going to have to get them memorized. We'll see if I want to give you that or not. Is 2 bigger than 1? So that has been vertically stretched times 2. Which means what? Fatter or skinnier? Skinnier, but he's not a parabola. He's a V, right? He's a V. So let's talk again. He's going to open up, right? Let's move the vertex to 1, 3. And then we have like a normal size V, a skinny V, and a fat V. This is supposed to be a skinny V, so nice and straight, not curved. This would be like the normal absolute value guy in red. We don't want that guy. We want a skinnier V than that. Skinny V. And I'll have you write the sentence this time. Why don't you go ahead and write it? Start with the graph of. The graph of. And if we do this right, we won't have to write the next sentence. The graph of, but tell your neighbor what you want to put next. Because I don't think we should put y equals x squared. Right? You got to strip the absolute value guy down to vanilla. Right? Strip him down to vanilla. So here's the question. Is it just this? That would be a line. Right? What do I need to make him be a V every time? What do you need? You need what? The bars around it. Are you with me on that? It needs to have the bars around it. Cool? So that's what has to change is the parent function, which is fancy for the vanilla ice cream flavor of this graph. So has been. And then see what you got. The graph of this guy has been translated 1 unit right and 3 units up and vertically stretched times 2. I went old school on here. I used to make people write by a factor of 2. You can just say times 2. Times 2. And when you get that sentence done, do our last problem of the day of graph transformation theorem. Label your 3 steps. Make a sketch. We don't need to write a sentence on it because we'll do it out loud. I forgot to put that on my sketch. Make sure you have the vertex labeled on your sketch. So what do you think? Again, highlighting for those who are visual learners like myself, has it been reflected over the x-axis? Yes. So this will make a V shape that opens which way? Up or down? Down. Translated, what did you put for numbers? -3, 1 or -1? -1. All right, so 3 units left, 1 unit down, and then step 3, it did happen, right? It did happen because this number, when you make him positive, is not a 1. All right, so 3/4. 3/4 is either bigger than 1. What happens if you multiply something by bigger than 1? Does it like stretch, which means grow, or compress, get smaller? What do you think? Stretch, right? So wouldn't that be vertically stretched times 3/4? Did I do it right? I don't think so. Shouldn't it be vertically compressed, right? I did it right. I didn't say it right because this number is not bigger than 1 in this case. So vertically compressed, which means he is fatter. So hey, what's the point? In 2 years, your junior year, you will take the most important test to you financially called the ACT. And that is a timed test where by the time you take it, you will have to answer 45 questions in 50 minutes. It used to be 60 questions in 60 minutes. Some of those math questions are easy. Some of those math questions are hard, right? What our job is to save you time. We are trying to teach you shortcuts. You will also learn how to graph all this stuff on a calculator your junior year, but it takes too much time to punch some of these things in if you have it memorized. So could you tell me, if this was a multiple choice question, without ever having to go to a calculator, let's do process of elimination. There are 4 choices right here. Eliminate some that you know it can't be.